morning, everyone. Today, we are going to unlock one of the most fundamental concepts in all of physics, which is acceleration. Now, we all know what motion is things moving from one to another place. But what makes things change their motion? What makes them speed up, slow down, or turn? That, my friend, is the engine of the change, which is acceleration. By the end of this session, you will understand not just what acceleration is, but how to measure it, how to see it, and how to use its mathematical power to predict the motion of anything in the universe. So let's get started. Good So let's look at the definition here. Acceleration is strictly a measure of the rate at which velocity changes over time. That means here I describe two scenarios. One is uniform velocity, another is changing velocity. So consider this first. Now, if car is going in uniform velocity means let's suppose it is 100 kilometer per hour, same speed, same direction. Now, if there is a no change in the speed as well as in the direction, means there is no acceleration here. Means initial velocity and the final velocity of this car is same. So the result which is acceleration is 0 meter per second square. So here speed and the direction are locked means they are not changing with the time. So that means the velocity is constant. The velocity of the constant means there is no change of velocity with the time. So the acceleration is 0. This is the first case. Now we move forward in the second case, which is changing of the velocity. Suppose the car is first stopped, then you drive slowly and you achieve some kind of speed like 100 kilometers per hour. First car is zero, means at 0 kilometer per hour speed, and then you achieve this kind of speed, means there is some kind of change in magnitude. Okay, so velocity will be changes. The first in the first there is a zero, and then it achieve 100 kilometer per hour. Now here I take example from 0 to 70 kilometer per hour in just 6.3 seconds. Means what? First, car is not moving, but when you push accelerator of this car and you got the speed like 70 kilometer per hour in just 6.3 seconds. So how we calculate the acceleration of this car? So for this, we have a formula like the final velocity minus initial velocity and upon taken time. Now, the final velocity of this car is about 70, or you can say in meter per second, we have a 19 meter per second. And the initial speed of car is 0, means 0 here, and taken time means 6.3 seconds. Now, if you divide this, you will get the average acceleration of this car is about 3 meter per second square. Okay, so this about these two scenarios in which one is uniform velocity, there is no acceleration, and there is a change in velocity with the time, so it must be have some kind of acceleration there. Now understand the concept of acceleration means the moment you step the gas to pass someone, you are accelerating. The moment you hit the brakes for a red light, you are accelerating. The moment you are turn the steering wheel to take corner, you are also accelerating. It is the action that changes your speed or a direction. Now this is where physics get a little more precise. In everyday language, we say accelerate to means go faster. But in physics, it more deep meaning. Velocity is a vector, which means it has both magnitude and the direction. Since the acceleration is the change in the velocity, means it is also a vector. So the direction matters in acceleration. So a negative acceleration doesn't mean that the slowing down in the mathematical sense, but it means that the acceleration vector is pointing opposite to the motion. This is what we call deceleration. In this, here I mentioned that the positive vector means what? The car is stationary and it goes this way, and you achieve some kind of speed. That means the acceleration and the velocity both in the same direction. That's why you get this more speed. You increase the speed. But in the other case, the negative vector means that what? The train is going some kind of certain speed, like you can say 31.9 meter per second. But we have to stop. Then you do some brakes, you apply some brake, and the train got deceleration. And how you measure it, as I mentioned earlier, that the formula of acceleration is final means we have to stop, and the initial, which is going with the speed of 31.9 meter per second upon the taken time means it will take some time to stop, okay, which is 90 seconds, and you will get this kind of figure. Now, here you got the minus value that indicates that the some kind of stopping means deceleration. In this, you got positive A because the this and this velocity and acceleration are both are in same direction. But in this case, they are opposite direction. How you get this concept? Now you understand acceleration as well as deceleration. So the question arises in your mind that how we visualize and how we draw a graph of that describes the motion of body. So here I draw that graph of velocity versus time. Here the black line it shows the trajectory of this body. Okay, now it starts from here. Let's suppose there's a car over here. Car at first it will be stationary. Okay, or you can say at rest means there's no velocity means at zero acceleration. Now it's starting from the rest and it will go and get some kind of uh, speed like 90 kilometer per hour. Let's suppose, and it attains to 0 to 90 means it shows the 0 to a point, okay, and it will attain some kind of speed like 90 kilometer per hour. Now if you take a slope of this curve at this part 0 to a shows the slope of the tangent equals instantaneous acceleration. A positive slope means accelerating. Now here you take some kind of tangent and you draw a tangent and you got the slope of it, and the slope is positive means you are accelerating this body or car. At the point of A you got the same velocity over the period of time means what? Car is going in the same speed, same velocity means there is a no acceleration here. Okay, now if there is a obstacle in the road, you push its brake and the car is going to the like 50 kilometer per hour speed, and you will get the velocity is very decreasing by the time, and you got the B point. Here, A to B point, there is a negative slope here. Now you can draw a slope here. First, you draw a tangent and you will get the slope. The slope is negative. So, what does it mean? It means that the acceleration is decreasing with the period of time. Means it's called deceleration. Okay, the object is slowing down. Here you can see the velocity is decreases with the increase of time. Okay, so the key principle is here is that the steeper the gradient means steeper, the more value of the slope you will get, the more extreme and the acceleration. Okay, this is all about visualizing the rate of change of velocity gives acceleration. Now there is a you can say equation of motion which are describing the speed of the body after some time. You will get the four equations which are totally depend on what the a is constant throughout the motion. Okay, you have to consider a is constant throughout the motion, then it will applicable this four equation. Okay, now first we understand what the equations tells about. So here the equation is like v is equals to u plus at. Here you see v is a final velocity, the destination where object is ends up means first there is a rest, car is in rest, then you will go further and you will achieve some kind of speed like 70 kilometer per hour. It is v represents v. U is 0 in this case because the car is at first at 0 kilometer per hour. Now, what is A? A means acceleration. And time is how much time the acceleration is going on, acting on this body. Means the duration over which the change is applied. Means if there is a acceleration apply on this car about 5 seconds, the time is this 5 seconds only. Okay, so this is a basic equation, and if you subject A here, so we'll get formula like this way. As we did earlier, that V2 minus V1 upon T2 minus T1, which is like this. V is the final velocity, V1 is the initial velocity, T2 is the final time, or you can say T1 is the reference time. Okay, so it will show like this. Okay, now your final speed is just your starting speed plus whatever you gained over time means A. So this is a very basic equation where the A is a constant. Okay. Now to truly appreciate the acceleration, let's look at the scale of it. It spans mind-blowing 31 orders of magnitude. One end of the spectrum, we have a massive slow accelerators of galaxies moving through the cosmos like this sun and moving around the sun. There's a no acceleration over here. Okay, the lowest scale of this spectrum. Now on the other hand, we have a extreme acceleration of subatomic particles in particle accelerator. Here, at this end, you see how large scale of acceleration over here. Electron orbiting nucleus, kind of nuclear physics. And the human experience sits right in the middle. Here you see family cars speeding up, free fall of the moon, the free fall near the Earth's surface, which is about 10, and standing at the equator, which is about like this. So this is the spectrum of the acceleration from lowest to larger. Now, everyday human experiences is quantum mechanics like this. So we move forward. Now we arrive at the one of the most important examples in all of physics, which is gravity. Here, the on Earth, we experience a constant uniform acceleration. due to gravity. We label it symbol G. Okay, here G has symbol, and we take a value of it is about 9.81 meter per second square. So it is basically acceleration due to Earth. Whenever you go on Moon, there's a some kind of other value depend on G. Okay. Now we often take as a 10. Okay. The direction, as we know, the acceleration is a vector quantity. So we have to must add direction as well. So strictly downwards toward the center of mass means if there is a ball here and there is a earth surface means the direction over here is this downward. What is the rule here? In the absence of air resistance, the Earth's uniform gravitational field applies the exact same acceleration to all objects, regardless of their masses. So, understand here that it illustrates that there is a ball here, okay, and there is a feather, okay, or you can say leaf here, okay. It is heavier than this leaf, okay. When you pull at the some height and you left on both hands, and you will get the ball is very rapidly touches the surface than this leaf. Why? Because here we have in atmosphere there is air. Due to this air, the ball is very rapidly getting a speed than this leaf. Okay, and hit ball first, then leaves. Now, if you don't have air here, and it's not present here, you have a vacuum. So there is a result is very different. In that case, we have a ball and the leaf. At the same time, they fall on the Earth's surface. Okay, so let's understand now capturing the gravity in the fractions of second. Here we took some did some experiment over here, and in that experiment we use stroboscope. So what does it mean, and what is it? It is a tool used to make cyclic, moving, or rapidly spinning objects appear to slow moving or stationary. Means ball is going on here, and you have to picture it clicks a picture at every 0.05 seconds. Means the increase after 0.05 second it click a picture. So here you see that there is a ball over here, and after clicking picture you will get this ball over here. After taking some time and you will get ball here. Whenever ball is going down here, and you will notice that there is a gap between these two pictures are increasing rapidly. Okay, here there's a no gap, there's a little gap here, there's an increasing of gap. On the other hand, you will also see this kind of ball like football, it may show some kind of discrepancy here. There's a no constant gap between this. So from this you can say there is some kind of acceleration over here. Okay, not if there's a gap between this is same, so you can say velocity is same, but not in this case. So you may plot displacement versus time squared, and you will get the straight line. Okay. Now, now for a long time, people believed that the ancient Greek philosopher Aristotle, who said that the behavior bodies fall faster than light ones. So this is the belief of the 16th century. Aristotle believed that there is a heavy body which is move faster and fall down fast than the lighter one. There is an illusion caused by the observing air. As I talked earlier, that there is air. You notice that the heavier masses, heavier bodies are falling very rapidly fast than the lighter one. Okay, so it is due to the air. Okay, but the one man named Galileo Galilei challenged this idea. He was a pioneer of scientific methods. He performed experiments rolling balls down the inclined planes to slow down the motion so he could measure it better. And he established that the absence of air means there's a vacuum. All bodies fall with the exact same constant acceleration, which I talked earlier. There's a no air, there is a vacuum over here, means there is a not dependent on masses. They get same g. This value is g is 9.8. Okay, so they got same velocity regardless the masses. Okay, so the Galileo Galilei proved that, and he established that the displacement is proportional to the square of times. Okay, this is a very important phenomena in our physics, and this kind of revolutionary. It took a simple observation and built the mathematical foundation for all modern kinematics. So the Galileo Galilei uh, challenged the belief of old. Okay, here at last you can see here there are four equations which are only applicable when acceleration is constant. If a is not constant, it is dependent on time, means a proportional to t square, t, some kind of t, then there is a not for you cannot use over there. Okay, so when we face or we solve some problem or examples, then we have to see that there is acceleration is constant or not. If there is a is constant, then we will use this for equation dependent on what you need. We use there. But if there is a say that it is a is not constant but variable with the time, or you can say this place, means we cannot use these equations in that case. Okay, so keep in your mind, and by identifying the knowns to unknowns, and a linear motion is the universe can be mapped and predicted with just these four fundamental relationships. When there is a is you can say a is or g constant, then we can use these four equations. Okay, near the Earth's surface, we can take g as 9.81, and which is about constant in near the surface of the Earth, near the surface. Okay, now we started. We started with concept of change, made it precise with vectors, gave it a visual representation, then captured it with the math, and we saw how it governs the motion of everything from falling ball to galaxy so far. I hope you guys understand this concept well. In my next class, we will see the projectile motion. We discuss things so far in one dimensional, but from the next class, we will enter in the two dimensional, and the famous 2D motion, which is projectile motion, we will see in our next class, and it is very important to understand many phenomena in our world. So, thank you for watching. Subscribe for more physics lectures.